Batagaika crater and what the future of the Arctic might hold. Permafrost is the leading component that contributed to the formation of Batagaika crater, but the word permafrost can be misleading. Permafrost is ground frozen for 2 consecutive years. While the definition is rather straightforward, permafrost and permafrost landscapes can be a little more complicated. For our purposes, focus on continuous permafrost, discontinuous permafrost, and the active layer. Continuous permafrost corresponds with the definition most clearly. It is simply ground that is frozen through for up to hundreds of meters. Discontinuous permafrost, however, is a mixture of smaller pieces of permafrost distributed throughout unfrozen soil and rock. Finally, the active layer is a section of ground that thaws in warmer months and refreezes in the colder months. We will come back to this diagram later. Before we talk specifically about the Batagaika crater and its formation, it's important to understand the regions at risk for permafrost-related hazards. Here we can see the entire circumpolar region in the north is at risk for permafrost loss. While permafrost does exist in other regions of the world, like in Switzerland, parts of South America, and around the South Pole, the majority of populations affected directly by permafrost degradation live in the northern hemisphere, where we have decided to focus. As mentioned earlier, permafrost is frozen ground, and like a frozen pizza, it can't really melt. It thaws. For permafrost to melt, temperatures would have to be between 1100 and 2500 degrees Fahrenheit. With that being said, thawing permafrost impacts our permafrost landscapes significantly. Warmer temperatures mean the active layer becomes larger. Continuous permafrost can become discontinuous permafrost, and discontinuous permafrost thaws further. All of these changes contribute to an unstable landscape. What once was frozen solid no longer has the same strength keeping it together. Batagaika crater is an example of what can happen in these permafrost-dominated landscapes. As permafrost thaws and occupies less space, thermokarst depressions, like the Batagaika crater, are able to develop. Batagaika has been growing for decades and will continue to grow. In this series of pictures, we can see Batagaika's growth, which coincides with warmer temperatures in the region. As the temperatures warm, permafrost thaws, and these large-scale depressions are able to form on the destabilized landscape. The Batagaika crater, fortunately, developed in an uninhabited part of Siberia, which is why it isn't a disaster per se. However, permafrost degradation is able to have serious impacts on infrastructure, like this office building in Norilsk, Russia. Pipelines and transportation networks face serious significant risks and can have huge economic and human impacts. On a larger scale, permafrost thaw disrupts the carbon cycle significantly. As permafrost degrades, more carbon is eventually released from the ground than is taken in. The abundance of carbon being released, primarily in the form of carbon dioxide, is a prominent greenhouse gas and impacts the climate of the region significantly. These greenhouse gases being released by thawing permafrost have led to an increased warming in the region, contributing to an increase in precipitation and even further accelerating thawing, which maintains this cycle and will continue to do so if actions are not taken to mitigate permafrost thaw. While no one large-scale permafrost-related disaster has struck and directly harmed large populations, permafrost degradation happens slowly and unseen until the damage is irreversible. Batagaika crater is in eastern Siberia, but events like this can occur over large areas of the Earth, with little being done to prepare for them.